Here's how we work banked curve questions. You're going to be given a bunch of numbers. We're going to use the condition that we just proved, that I just proved. Hopefully you watched the last video, or you'll need to figure out where to get it from. I'm not going to reprove it every question. We get this v squared equals tan x. That's our banked curve equation. It tells you the threshold speed a car could go if there was no friction. To work a banked curve question, we're just going to plug in our given numbers and calculate the speed. This particular one I made up 15 meters, g is always 9.8, and then we'll take the tan of 15 degrees. When we crank all that out and take the square root, I get the number 6.3. That's in meters per second. I need to compare that to 30, so converting the 6.3, it converts to roughly 23 kilometers per hour. The last step of our banked curve question is to do a bit of logic. The question says a car goes into the curve at 30 kilometers per hour. The physics says the fastest the car could go if there were no friction was 23. Since we're going faster than that threshold speed, the tendency would be the car would drift up and out of the curve. It's going to fly outward. Friction is going to prevent that from happening by being downward. If we had done the math, or if the question was different, if the car entered the curve at a number lower than 23, then the danger is the car would drift in or fall into the middle of the curve and friction would be uphill. So really for a banked curve, you need to know the Rg tan x equation, crank out the speed that the car could go, and then use some logic. Compare the speed the car is going to what the equation gives.